There we go. Okay, so log on to SQL Developer first. And then on Monday, we did primarily like, we did two things actually. We did use decode function, and then we did contains, basically doing text search. So to be able to do text search, make sure that text column have to be indexed. So you have to create the index like a context index, and then the searching of the words will be much faster. Otherwise, you'll see that it's going to be very, very slow. So let me log in, okay, and then I'm going to just do one of that kind of questions. So let me do, first of all, describe responses. Okay. So this table has a bunch of columns, ID column and text column. Text column is the main column that contains responses. So that is a place we will use text search, okay? So now let's say if I want to find responses that with words like sounds like a Unix, with words one sounds like Unix, and then other one and the other one possibly spelled like variable. Okay, so I misspelled that word. Okay, so the word, so basically in this case we're searching for two words. So we're going to say select text, or we can have ID also, responses, text column from responses. Then we say contains. Okay, so the syntax is pretty simple. Say looking for text column, but then we have two words. Okay, put both words inside a single quote. The first word is Unix. But then the second one and the second word is a variable. Okay, but the first word I don't know the spelling precisely, so I'll put I use a sound search, so that I will put like exclamation mark in front of it. But the second word variable, I'm not sure I spelled correctly, so I will just use fuzzy search. Okay, so that and then close this contains function, and that's greater than 0, so that we'll be able to find the two words. And so you can have combination of precise words, fuzzy words, or based on sounds, or based on the word stem to search for the documents which contains those words. Okay, so I'm not sure whether we can find anything, but the syntax is correct. We did find one. Okay. Okay, so if there's no questions, then we are going to move on. So what we're going to do next is we are going to do something called the rundown search and rank search. And the foundation for that is based on, okay, let me put that, rank search and rundown search. Okay, and the foundation for that is based on row number. So what is a row number? Let me show you a query or table. Maybe select star from EMP. Now, if you look at this query result, you have those columns, right? There's the EMP number column, ename column, job, all that columns. So we have been using those columns, but you probably have not paid attention to the side here. This is the row number here. 1, 2, 3, 4, 5. Okay, so this is actually like a meta column. It's not managed by table itself, but Oracle will automatically assign each row with a row number. So this will be the original row number in the table. And you can also do that with a query. So if you run a query, say, for example, if I want to find job equals to, say, manager. Okay, so in this case, we are doing a query, and then we can also order, okay? Let's just say sort the result. So order by, for example, ename, okay? Order by ename. So in this case, we are getting just basically get the result from this query, and this result for each record in this result, either will also have a row number. Okay, so now you see here that you have row number 1, 2, 3. Okay, so those will be automatically managed by Oracle. So it's called more like a meta column. Okay, so we can just use that this row number to do both rank search and random search. Okay, so let me tell you what we're going to do first. First, let me just use example, and then along the way I'll explain what is happening. So let's say if I want to find out the first, the highest 5 salary earners, top 5 salary earners. So let's just put paste it here. Okay. First 5. Oh, this is just the first 5 records of employee table. Okay, so that so we let me just do that based on that the row number for the table. We can just do the query easily. So select first 5 rows start from EMP. Okay, well, just a row number, and then that row number is less than 6, right? So that would be first 5 rows. Does that make sense? Okay, so those are 5 rows you can select. You get from the original table, and that is not very interesting because that basically just saying that those records are inserted in the order that they were inserted first. They were created first. Okay, and if you want to find out the last 5 records, what do we do? This is what I do. Okay, let's say find the last 5 records of the EMP table. So in that case, what it would do is let's just order. Let's do like a. How do we do that? We can, because we don't know how many records are there. So we still should use something like this to just like a row number less than something instead of a row number greater than something, because you don't know how many rows you will be getting. Okay, so what I will do is I will just try to reverse the original order, and then we'll do it. And so select start from. So here, what I will do is I will reverse this original table's original order. So I will do select start from EMP, and then we say order by row number, and then we'll do let's do descending order, DESC. Okay. So from this subquery, I will just basically just reverse the order of the original table, and now we can just say where row number is less than 6. Okay, so that will give you the last 5 records. Does that make sense? So I will reverse, use a subquery to get like a result, and the result is actually reversed. Okay, and then we'll do less than 5, less than 6, which is actually 5 records, last 5 records. Okay, so now you get a different result. Okay, so based on this example, these 2 examples just demonstrate that we can manipulate the row number for other more meaningful queries. So first meaningful one is, say, if I want to find out the top 5 salary makers, you understand that just find the top 1. Do you remember how you do that? This is how we did it. Okay, so you just find the top 1. Let me do that first. Okay, and we have to use like a tuple variable to do it. So find top Let me put a comment here. Find top 1 salary maker. So the query was like the query will look like this. Okay, so you're going to in this case I probably don't need a tuple variable. So select ename, job, or maybe on salary. Okay, from EMP. Well, you have to make sure that salary is the biggest salary for the entire company. So we'll say select max cell, and then from EMP, right? So that will give you the top 1 salary makers. Okay, so you find an employee whose salary is the maximum, right? So that should give you the top 1. But now the question is, how do you get second to the top? So, okay, by following this line, it's not going to be easy. So let's just try to do that using this row number. Okay, so we'll do this. Select top 5 salary or no. So is I will get the employees' records and then rank by their salaries in descending order. So that means the largest salary will be the first row, second largest will be second row. So I'm going to use subquery to get a list of employees, and then these employees are already sorted by their salary in descending order. And then we can say, well, row number less than 6. So we use 5. Yeah, we use 5 here. So there's that less than 6 here. Okay. So now let's try to formulate the subquery. So subquery should be pretty simple. Just say select star from EMP, and then we'll say order by cell, and then we say DESC. So they're in descending order. Okay, so now this subquery give you, this query give you a result. The result is actually just original table, but now is ranked, is ordered by salary. So the largest salary will be on top. Second largest will be on second, so on and so forth. And then you select the row number less than 6. Does it make sense? So this is how you can do this kind of so-called rank, this more like a rank search here. So let's try and do. Two salary makers. So the idea will be the same, but in that case will be order by salary, but in ascending order. Connecting. Who have problem with connecting to network? Somebody was saying that there's connection problem.
Professor.
Yeah.
Your screen share is frozen.
My screen shows frozen?
Yeah.
Oh.
It still looks like you're running the last. Okay, now it's.
Oh, it's okay now. Let me check which network I'm using.
Also, I had a question about my result.
Yeah.
It shows Lisa as the top salary maker, but she has a null value for salary.
Oh, okay. Lisa. Okay, so that's because your table has a Lisa in there with no salary. So in that, let's say not lost. Add that keyword to see whether it make any difference. Do you still have network problem, connection problem?
Keeps going in and out.
Oh no, okay. So is that my side or is somebody else? Or is other side, your side? It's probably my side, huh?
I think it's your side, and that fix did work. Thank you.
Okay, great. All right. Okay, so it's working now. Can you hear me? Or can you see this screen like my mouse moving? Can you you see it?
Yes, it's working now.
Okay. So it's probably because I was notified that this area has like a service outage. So we'll try our best. I think hopefully we can get through today's class, and then we'll have like 2-3 days without any trouble. All right. So let's do this next question. So
What do you want us to do if it cuts out? Should we like message you or just turn our microphones on?
turn on microphone, trying to talk to me. I hope it is. I don't know what to do. So
Okay.
if my network get disrupted, then what do we do? I don't know what to do.
All right, that's okay.
Okay, so probably I can just use my cell phone to make a connection. I hope. Okay, so let's say name, and then salary from, and then this time we're going to get all the employees again, but order by salary. But in this case, we'll do ascending order, ASC, right? Ascending order, and then we'll also do now's last, just in case you have null values. And then we say from where row number is less than 6 again. Okay, not 6, 3, right? 3. So this will give you the bottom 2 salary owners, only 2 there. Okay. All right. So this basically give you this the row number give you like a alternative for finding top salary owners, bottom salary owners, all that. And we can even use this same mechanism to do rundown search. So for example, if I want to find out 2 rundown employees, you might wonder, why do we need that? Why do we need to find out rundown employees? Well, there are many. I can just imagine a couple of applications. First, maybe the company has some kind of a mechanism to select a rundown employee to get award, get recognition. That's not very likely. But the more realistic situation is that if you set up like a gambling system, all right, so you really need to generate a rundown records, right? So not really just gambling, for just if you visit equals, I'm not sure whether you notice that. If you go to like a quiz a day, so basically every day I would generate a rundown question, get a rundown question from the test bank, and then display that as question of the day. Okay, so that could be useful. Yeah, and another possible use would be, say, like some kind of like a test site, like SAT test or what kind of those graduation tests, GMAT test. They generate rundown questions from the library. So that would be very useful to search for rundown questions using this approach. Okay, so how do we do that? So basically, we are going to do the same thing. So what we do is we have to make sure that generate results by randomly. So basically, we will shuffle the entire table, entire records, all the employees' records, and then we say row number less than what, 3. Okay. So let's try to select. Let's just select start. Okay. From, and here the subquery, I'm going to shuffle the results and then say where row number is less than 3, because we're looking for 2 random records, right? So now in subquery, we just need to get all the results ordered by some kind of random number. So we do select start from EMP, and then we will do order by. So this time we order by not by anything. We are ordered by some kind of random number generator. Okay. So for Oracle, there is a function you can do that to generate a random number, and the function name is called dbms. and then rundown. And then use that function to generate the value. So value. Okay. So you order by this rundown number, then of course your result will be just all shuffled, will be rundown. Does it make sense? Okay, so this is how you generate rundown numbers in Oracle. Okay, so let's run that. Okay, get to that, and if you run it again, should get different result, right? Different people. See the point? So you could use this to generate, to pick up one rundown employee, then you change this to just say less than 2, okay, and then just 1. So this will be the lucky employee for the day. No problem, right? And next, let's try to do rank, okay? So let's say that's probably useful for statistics, so for data analytics. So so we have data, and then we're trying to get so let's say I want to show employee commissions, but also along with that, I want to show what is the rank of the commission, the first rank, second rank, third rank, something like that. Okay, so let's try to do that question. So to do that, you're going to use a function called a rank function. Okay, so find the employee's commission with ranks. Okay, so let's just do the first part first. Select ename, and let's put a commission here. That's what we want to do. Okay, and then next I will do rank. I will put a rank function. And when you do that, you have to say over which one. So now you have to say you want to order by commission now inside here. Order by commission. Okay. So so let's do descending order. So that largest one first. Okay. So order by commission. So rank over this. So that will give you all the commissions ranked. So the highest one will be 1, second highest will be 2, so on and so forth. And of course, in this case, we also have null values, so we can just put null last. Okay. So that way the commission will be ranked, but those if they have missing values, then they will be put in the very back. Okay. So this is how we can generate use the rank function to generate rank over any value. So you can just order by salary, order by something else, order hire date. Okay. And then we can also give a name. So this is as rank. As rank. Okay. So that would be just give you another column name. As let's just change it to commission rank. Commission rank. Okay. So otherwise it'd be confusing with the name of the rank. All right, and then we say from EMP, and then let's also order by commission in descending order. Okay, so that way the top commission will be listed in the first. Okay. And then let's also do null last. So that way the missing values will be put in the very back. So what is essential is the rank function. When you say rank, then you say rank over which column, okay? Which is over the com column, so order by com. So if you rank over hire date, then say order by hire date. Make sense? And this part is just display the result, okay? So without that, then you're going to say the first employee commission and then rank 2, second employee commission, then rank 3, something like that. But now I make all the commissions, rank sorted from largest to the smallest. Okay, rank. All right, so this is how you get how the result looks like. So 1400 will be largest one, rank 1, 500, 300. So every null values are ranked like 5 here because they are lost. Okay. All right, and next I want to do so-called the cursor search. causal. So basically what does it mean is, so if you have, let me give you an example. I will explain that to you. So if you want to looking for like a department, and then within the department, there are many employees, right? I also want to show the employees inside each department. Okay. So now if you look at the department has department number, let's do that. Okay, select DEPD number, D name, and the location, right? From DEPD. Okay, so that is pretty easy to understand. However, what is new here is I want also inside same query, I want to get all the employees for each department that you listed. Does that make sense? So for that, so there's no single employee, right? So each department has multiple employees. Okay. So what I will do is I'm going to use SQL statement to get those employees for the department we're looking for. Okay. And then of course, the employees we're looking for must be belong to this department you're looking. So here I have to use tuple variable to begin with. So let's say department D, and then a D.EPD number, D.D name, and D.location. Okay, and then for subquery, the subquery is going to create multiple results, right? So I'm going to say that's the causal, and the causal is actually just like in programming class we learn string radar, right? String radar is kind of similar idea. So basically, it's like a matrix area that will help you to show put data like a tables, put like a table information, which has rows and columns. So causal is kind of like that. Okay, so it's a very important concept for PL/SQL programming. So that is, I told you that PSQL is extension to SQL, and which allow you to have like a variables and loops, all those kind of concepts to program database. And the causal is one of the concepts in there. Okay, so what I will do is I will just make that causal, and then actual data to be stored inside the causal will be obtained by SQL statement. So what we need to do is actually pretty simple. So basically, we're going to select get an employee. Let's just get employee name, job, hire date, or maybe salary from EMP, okay, from EMP, and then we have to make sure that the employee we're looking for has to be from this department. So department number must be matching that D.DEPD number. So where EMP.DEPD number equals to D.DEPD number. Okay, so that it's the tuple variable is playing the role to matching that, for each department you're looking for, and then you're trying to get all the employees belong to that department. Okay, and this causal, this whole thing is a causal, so you can actually give another name. So let's just say as employees. Okay, now let's say if you run this using SQL Plus, which is a traditional console environment, interactive environment for writing SQL statements for like a query, for making queries, you will actually see that it will be displayed as like a subtable inside each department. But here, since we are using Windows environment, using SQL developer, which does not have a capability to show you a table inside a table. So you will see something a little bit different. Let me see what it's going to get. Okay, so you get something like that. Okay, so you get department number, or that each row is for one department. But then when you get into the employees for each department, so you actually get something like this. Okay, this is actually causal. Okay, this is the causal. But if you use SQL Plus, this will be displayed as like a subtable. Okay, but this does not have the capability of doing that because it's SQL developer just showing basically result as like a table. does not have a way to show a table inside a table. So this is actually a small table, okay? So this is another table, this is another table. All right, so this is, so basically we are using tuple variables another time, second time. We can also use tuple variables inside here. Inside we did not use tuple variables, so sort of ename job, title date. From EMP, so we can just do that EMPE here. And then if we do that, then you have to change this to e.ept number, and then say e.ename and e.job, and then e.hire date. Okay, so that would be very standard tuple variable, right? So basically using this D to looking for the employees belong to D. All right, and then we make, because this gives you like a table, right? So I'll show that as a course. Okay, and then the other part will be just standard. Just say each department has those information. Okay, so this will give you same result. Okay, so I think that finished our first topic about rank search or rundown search. Okay, let me say, was anybody have questions? I hope my internet is working so far. No problem. Anybody? Does anybody have questions, problems?
No, you're good.
Okay, very good. Now let me move on to next topic. It's called hierarchical queries. Hierarchical queries, not just hierarchical queries, also hierarchical queries with so-called recursive subqueries. Okay, let me copy that. So let me explain to you what is recursive first. Okay. To understand the recursive function, recursive is actually is kind of like a function call that we are trying to program a function. The function call the function itself. So let me explain to you what is about. Okay, so since in programming class we did not really cover that concept of recursive functions, but it is there. So let me explain to you what is recursive function, and then we'll come to this recursive queries. So let's create a new whiteboard here. Okay, so recursive function is, so we're trying to program a function, let's say a function of something like x here. Let's just try to write that as like a code. Okay, write something like a code here. So yeah, let's say I have a function just trying to say that is created like a result as double, and then say function is name is say do it, okay, and then say this is integer, some kind of x in here, okay, and then you're trying to program that function based on this given input, and then trying to generate output, right? So while inside that you call this function itself. So somewhere here you may say double y equals to do it. You call the function. That function you have not finished in program yet, but you call the function itself to do some part of the job. Okay, so suppose you're trying to put some kind of like a 23 here. Okay, so you say that this is recursive. This is function call that call the function that you are trying to program at the same time. So let me give you a more concrete example of how this is done. Let's just say, suppose I want to find out. Let's say function is factorial of n, fn equals to n factorial, okay? Suppose I'm trying to program the function to do factorial. Make sense? So if for this n, we understand that if n equals to 1, then this is 1, right? 1 factorial is just 1 times itself, right? So that is easy, okay? But then what about function 2, factorial of 2? That should be also easy. You can just say 2 times 1, right? Okay. Now, let me just all of a sudden, let's say I want you to do factorial of 500. 500. Then you feel that this is difficult. This is difficult because I don't know how to do that. Okay. So what you can do is instead of doing that, I will change this to 499. Let me change it. Let me use smaller number because I don't have time to explain the whole thing. You know, that's just too much time. So let me do smaller number here. Let's just imagine that I will try to do F10, okay? F10, which is 10 factorial. So how do we get 10 factorial? So it's supposed to be 10 times 9 times 8, all the way to like a 1, right? But let's say that my function, you know, then I have to write like 10 steps for doing that. So what I would do is I will reduce this just to 10 times F9. So I try to do factorial of 10, but then I reduce the function or reduce the problem to just 10 times F9. Okay. And then you'll see that, well, F9 is easy. F9 is no, it's not easy. F9 is something we also don't know. So we can reduce that further. We can reduce that to 9 times F8, right? Get that? So F8 is still not known. So I will reduce that further. I will make this F8 equals to 7 times F6. Good idea? And then do it again. So F6, I don't know how to, hold on, it's F8. F8 should be 8 times F7, sorry for that. Okay, and then you're going to do F7, F7 equal to 7 times F6. So every time you trying to do a larger number, you reduce it to smaller number, and then you gradually reduce it, and then let's do F6. F6 is going to be 6 times F5, right? Okay, and then F5 is going to be 5 times F4. Okay, so you see that the problem is essentially reduce, and then F4 equals to 4 times F3, and then F3 equals to 3 times F2. Now you get it, right? And then F2 is equal to 2 times F1, and F1 is already something we know, right? We know F1, which is 1 right here, okay? So now the whole problem is reduced to that, you know, the simplest case. So this is a function, recursive function. So trying to solve a larger problem, but the larger problem is difficult to solve, so I reduce the simpler problem. Okay, if that simple problem is still difficult, then I reduce it further, reduce it, until to the point that I don't need to reduce it anymore. Okay, so this whole thing is called a recursive function. All right. So how is that related to our problem, to our query problem? Well, we have same kind of similar issues here. So let me give you a question first, and then we'll explain to you what is happening in there. Okay. So now let me give you a question here. That question is, I want to get all the employees in their hierarchical order of supervision. So in other words, I want to get the employees, list the employees in their command chain. In the order of the command chain. Okay, so let me paste the question here. Okay, so let me put this into multiple lines so that I don't have to. This is 2 dash. Okay, and then let's just say don't have to wrap. See multiple lines here. Okay, so now let's say we want to find all employees in their hierarchical order of supervision. So the president will be supervise vice president supervise mid-layer managers, and the mid-layer managers managing bottom layer, you know, the first line managers, and those managers will supervise other employees or another managers, right? So how do we get from this employee table? How do we get this kind of listed employees in that order? Does that make sense? So here we are essentially we need essentially creating some kind of query that, you know, we list presidents first, or list those employees who does not have managers, who does not have manager numbers. So yeah, manager is not. So that part is easy. We'll say let's just do E then, and then Is that all we need? Ename, and also maybe just put let's put EMP number also. Okay, ename EMP number also. Let's put manager here. Okay, from employee and where manager is now first. Okay, so that will be just like we do F1 here, F1, so factorial of 1. Okay, so that part will give you all the employees that does not have any does not have a supervisor. Okay, so there's no manager for those employees, right? So basically, just managers, top layer managers, top layer employees, like a president who does not have a manager ID, manager number. Does it make sense? And then what we do is I'm going to start with that to gradually create a new table. Okay, and then the next layer I want to source is those employees who have a manager which belong to these employees. So those will be like a vice president, right? Okay, and then after that I add those employees to the table and I start to build. Okay, I gradually build, and then finding employees who have manager IDs, who have manager number, is same as the employees in the existing list. So let me try and explain what we do here. Okay, so first we'll build a table, put a new table, build a new table. Okay, step by step. First, add a president to the table. Next, add those employees who are managed by president. Okay. And next, add those employees who are managed by, so this would be, so like a vice president, right? Like vice president. Okay, who are managed by president. And then we are adding employees who are managed by vice president. And then this process will continue. Okay, so we are building the new table step by step, and we just gradually add more rows to it. Okay, so now let's say, how can we do that? How can we add, how can we create a new table like that? Okay, so the way the syntax is this, just as the ways, okay, and then first of all, give a name of the table. So let's say that we can call that T, okay, call that T. And then we are going to give a column, so which columns we are going to need for that table. Now, I will just need ename column, ename EMP number also. Let's say ename EMP number. Okay, EMP. So you don't have to use exactly same column names. So I will just use different column names. Okay, I'll just say employee. Okay, and then EID. And then manager. Okay, I'll create new columns, new column names. Okay, so as, and then we are going to use subquery. So as here is automatically added for this. This is not added yet. Okay, so let's just say parentheses here. Okay, parentheses as this, and then so now if we stop here, then you say that this table is going to get employees, get those presidents, inform just one president, right? The president use the president rule to build this table. Of course, we have to make sure that this name has to be changed. Okay, so this name will have to be changed to as employee. Okay, and then employee number as EID, and then manager manager ID as a manager. So let's change the name here. Okay, so that way we'll be matching those columns. All right, so this is the first step, right? This is the first step. So now let's come to the second step. So the second step will be select ename. Hold on. Second step in this case will be we are trying to look for that table T to try to get next rows to be added. Okay, so we are going to select employee and EID. Select employee here. And the EID here. And the manager. Okay, from what? We say from T. So this is recursive. You see that? So you are trying to build a query that based on the query you are trying to construct. So that's why it's called a recursive here. So what do we do here? We are trying to get those those columns, select those, okay, from this table, from the table T here. And then we have to say, well, the manager we are looking for has to be has to match the employee. Let me see. We probably have to use both. Let me see what we do here. Hold on. No. Actually, I'm wrong. So actually, we have to select from EMP table also to get those employee names and the EIDs. But then we have to make sure that we are referenced to the T to get manager number. So I will have to use both. Okay. So I will do this. Let me do this. Okay. So E name as employee. Okay. And the EMP number as EID. And the manager as manager. Okay. And then say from EMP and T. Both. Okay, so now reference back to this employee, this T table. Then we have to connect these two tables. So where T dot EMP number, EID, sorry, T dot EID. So now we have reference to the T's column name, not EMP number anymore, right? So T dot that equals to EMP dot. So here we are looking for those managers, those employees who have a manager number equals to the T's employee number. So this will be the recursive query, okay? And then, so essentially the query we are going to build consists of two parts. So first, this is the initial part, okay? That's the initial part, get those president. And then we're going to next set of records, which may be vice president. And then there's a vice, and then that's not enough, right? We'll have to continue to add more. So we are going to say union all. So remember, if we do union, that would be just one query union, but now we say union all. So this one is recursive. You're going to get many of the set results, many of the sub queries. So I union all of them. Okay, so that will be the way we build the temporary table step by step. Okay, does it make sense? And after that, then with this temporary table, we are ready to show the result. Okay, we'll say select EID, employee, and the manager from T. So then the whole thing will be, this whole result will be displayed as hierarchical order. Okay. Now let me pause for a second and see whether anybody have questions. This part is probably the most difficult part in this class we are going to cover. So just take time to digest here. Okay, so let's run it and then we'll see whether there's any issue, and then we'll start to work to solve the problem, solve issues here. So here, first one is president, right? Kim, and his EID is 7839. Okay, it does not have manager number. And then the next set of employees has to be supervised by Kim, right? 7839 as manager number, 7839, 7839, 7839. So the three employees are supervised by Kim. Make sense? And then the next set of employees will be supervised by one of the three employees, right? By Jones, Blake, and Clark. See that? So for example, Ford is supervised by 7566, right here by Jones, right? And then 7698 by Blake. Okay, so that'll give you like order of a command chain of the employees. So the top will be the the employees who is the top of the company, and the bottom will be those employees who are not supervised, who are supervised by other people. Okay, who does not have subordinates. Okay, now let me say whether anybody have questions on this one. So the first part is easy. Get those presidents who has no managers, right? No managers. And then the second part, then you're going to join actually. You're going to join EMP table with the table you are constructing. Okay, why do we need a current table? Because we need the current tables: employee number, employee name, and the MIG manager number here. Okay, and for the employees I'm looking for, we have to make sure that those employees are looking for have manager number matching the T's EID. EID is same as manager number. EID is just same as employee number, right? The EMP number is the same as EID. Okay, so you're matching those employees who have a manager number same as EID of the table you are constructing. This temporary table you're constructing. Okay, but that of course involves many steps, right? So you're going to do many of the subqueries. So you'll see that there's a union all, which will combining all of them. So this is actually join, right? So we do the like a equal join, but we can change that to just like a regular explicit join. So let's just say, well, if we do that, say EMP, okay, say inner join T on, okay, on what? EMP dot manager number equals to T dot EID, right? So that will be how you do that the join, explicit join. Okay, so it's the same idea. So same you get the same result and the same idea here. Instead of using equal join, you're using explicit inner join. Okay, now let's see whether that question is clear. Okay. Next question. Let me just propose the question first, and then let's see whether anybody has idea how we do that. Okay, so the question is, let's say I want to find out question here. Okay, find out the years in which the company did not hire any employees. Okay, now it's tempting to do something like this. You say select Tucha, okay, Tucha, and then say hire date, and then just say why, right? Oh, single quote from EMP, and then say group by Tucha again. So while I go into new ones, I'm trying to review old ones, old problems. Okay, and then we say heaven count of the employees equal to 0. Okay, it's tempting to do that. So you try to group all the employees by their year number. Okay, and then if the year number has the count equal to 0, then those employees did not hire any employees, right? So it seems to be right. However, this is not correct. So we have dealt with this kind of problem before. So remember, it's trying to find a department that has no employees. We cannot just say select DPD number from EMP group by department number and say count equal to 0. That will not work either, right? So that's same idea, same problem. Because if you already have the employee, the year inside the employee table, then you're not going to have this count equal to 0. Make sense? So you will have at least one employee. Otherwise, you're not going to have the higher year in employee table. So that's why this is incorrect. Okay, incorrect. Okay, but then for department table, department number information, then we can get all the departments from another table. So remember, we do select DEPT number, DEPT number, DEPT number from DEPT, and then we say minus, and then we say select DEPT number from EMP. So that there's something wrong here. What's wrong? Oh, I put a let me see. Oh, this parenthesis must be outside here. Select. Okay. So select department number. Then those are all the department numbers, and then you minus the department numbers from EMP table. Then those employees. So this is the correct one. Okay, correct one. However, we cannot use this approach. You understand? Because we don't have a reference of all the existing numbers. We do not know what are the existing numbers. Okay, so to check. So only thing we know is that for inside the employee table, each one will have a higher year. But what about the missing ones? The missing ones are not given here. It's not given in any table, right? So this is the problem. So how to find the year, all the year numbers. So that is the problem. Okay. So that is, you can think of that as almost impossible to handle because there are so many year numbers, right? Starting from what? 0, 0, 0, where even before that you have year numbers too. And then to the future, you can have any year numbers, right? So that would be infinite number of year numbers, okay? But of course, the problem we are trying to find is probably just looking at years that around the time the company started to work and started to exist, and then we can looking for up to today's year number, and then say within all those years, which years the company did not have fired any employees. So to do that, we need to find out what is the earliest hire date, earliest hire year in the EMP table. And from that, I'm gradually adding 1 to the table to make a new year numbers, all the way to today's year number. Okay, so that is ideal that we are going to do that. So we are going to use hierarchical search again. So we're going to build like a template table, which will get all the year numbers starting from the very beginning of the year, which is the first way in which first employee was hired, and then we gradually add a 1, and all the way to today's. Okay, so we'll get a list of years from the earliest hire year to today. And then we check, say, which among those years, in those years, which year we did not hire any employees. So then we can use minus or use some other subquery to do that. Okay. So again, we are going to create like a template table. Use this hierarchical recursive query. Let's just call that T again, and then we are going to have just one column for the table, which is just year number. Okay. With that is the year, and then parentheses here. And then say as, okay, that's the table we are going to build. As, put a parentheses here. So the first part is easy. We're going to find out what is the earliest year. Okay, so we're going to select two char, and the hire date. Okay, and then we're going to get a year number. Okay, let's add a year from EMP. Okay, and then where. So actually, in this case, we don't need to use where. We just need to find out what's the minimum hire date, right? Just the minimum hire date. So there's no need for selecting cases. Okay, so we just need to replace hire date by minimum hire date, min hire date. So from the minimum hire date of all the employees, I will be able to get that all is the year number, right? All is the year number, okay? And then the next query, the recursive part. So let me just do this, put this. I don't need to put this in the parentheses, so just do this, just do the simple way. So let's say select year plus 1 as year again. So from this table T, I generate the next number, okay, from T. Okay, so that's what we are going to generate the next number. So the first number will be the first hire date, and then I'll just add 1 to it. Okay, and then we'll say union. We can union all. Okay, so we can do that first, union all. Okay, and then we need to finish the next query. So we probably it's easier to read. Just put this inside the parentheses. Put this inside. I think I had yeah. So I already have the 1 here. So let me put this. So that's just for readability. Okay, I'm going to close that here. Okay, and then we'll put union all here. So let's finish the recursive query first. Okay, so I'm going to select year plus 1 as a new year. So first of all, I get the first year, and then I plus 1 to get a new year. So there's one simple problem with this. So this is a 2 char. This is just give you characters. So if you have like a year, which is char and then plus 1, that you're going to get some kind of bugs. Okay, so Oracle is generally very tolerant of those kind of conversions, but for this plus add operation, we need to make sure this year number is really like a number. So we have to change this to 2 number. So remember, this is just like convert to number. Okay, 2 number, and then put everything inside as 2 number. Okay, as a year. So the chart, get a chart like a 1981 inside the character or inside the single quote, and then we change that to real number to get rid of the quote, and then say that's a year. Okay, and then this year plus 1 will make sense. Okay, from T. All right, and so what do we just need to make sure that the T we are looking for has to be this year, the year number we are looking for. Okay, the year number has to be somehow not has to be less than today's date. So have to make sure that year number is less than today's year number, which is also use 2 char first. Okay, 2 char, and then sys date, and then get the year number here. Okay, so that will give you a character, right? So then we'll have to do 2 number again to convert that to year number for today's year. Okay, so I'm going to do 2 number. And then put this inside again. So there are too many parentheses. Just make sure you manage that. Okay, 2 number and then 2 char. So just starting from the the inside. The most inside function. Check this. This one is closed by this one, so it's already matched that. And then this one is matched by this one. Okay, and then this one is matched by this one. So it's actually you can tell that is whether there's any parentheses has not been closed. Okay, so look at here. This subquery, this recursive part is going to get a new year number as just using the based on the one you already have. And the plus 1, and then you have to make sure that the year you're trying to get is less than today's year number, or less than or equal to. Okay, we can do it less than equal to. Now we're including today's just this year, 2020. Okay, and then we'll do union all. Union all. Okay, and then this will give you a list of year numbers from very top to the very bottom. So I'm going to close this parentheses in here. Okay, so that way you see that this one is matching which one? This one, right? So it's matching this one. So it's closed here, and this one is closed here, and this one is closed all here. Subqueries. Okay, so with the list of years inside the T table, and then we are ready to do our main query. So we just need to make sure that we select those years from all the tables, and then we can do what? Do minus, right? So we can just say select, okay, year from T, okay, from T, okay, and then we'll just say T dot T's year number. So make sure that year number is not in the list of existing years inside the employee table. So where year not in, okay, which is like a minus. So now let's do select to chart first, hire date, and then Y, and then from EMP. Okay, so that will be all the year numbers that have employees. So we just need to make sure that year we are looking for is not in this list. But now we have to convert this to number also, right? So to number. Okay. There we go. And then semicolon. Okay. So just the main difficult part is just building that using the recursive query to build a temporary table to get a list of years here. And then the next part is pretty simple. Just say select in the year the column from T such that this year is not in this list. Okay. So as long as the employee have is hired, then this hired year will be inside this list. Okay. So just get not from this list. Does that make sense? It's pretty complex, I think, but if you digest carefully, then you just follow this example, just do a few more examples, a few more similar examples. You should be able to. I think your homework has one question like that, so you should be able to understand the idea of how to use how to do recursive queries. So recursive query, basically your first part is just like an anchor part, just like the initial part, like just when we do F1, like factorial F1. So that is, the simplest case, okay? And however, all other problems will be reduced to simplest problem, the simplest case, okay? So here we find the year number, the first year number, okay, the oldest higher year. And then from that, we just gradually add 1, and then get the next year number. And then do it again, we do the select from T, right? So we do it again, then we find another year number, add all the years, and then eventually we have a list of years from the beginning year, from the first year to this year. And then we can just do this main query, which is not that difficult, right? Okay, I think let's run that. I will see whether we get all the results. Okay, so we did get a result here. Select. Well, this is not auto, so let's just auto then. Well, year not in that, and then let's say auto by year. By year. Okay, let's say in ascending auto. Okay. Okay, so 1983, no employees hired, 5, 6, 3, 4, 5, 6, and then 8, 88. So that means 87, somebody was hired. Okay, so you get a list of employees, list of years. So that basically just how how this hierarchical recursive query is solving problems. Unfortunately I do not have time to do more examples, but the most the most prominent example, most useful case is doing like a command chain. Okay, command chain. So that's not just for regular command chain. You can also do that with product, some kind of product assembly. This products, but some product may be used to make other products, and so there may be some kind of like a chain of usage or assembly there. So you can use that same kind of idea to generate that which parts is kind of like a assembled does not require any other parts to be assembled, but then you gradually follow the chain. Okay. So anyway, if you in real business problems, if there's anything that you want to display the results in hierarchical order, then this is the way to go. Okay, this is hierarchical query is the way to go. All right, so I'm going to stop here and let's see whether we have any questions. I think we already finished all the examples, all everything. So for this week, you have 12 questions to do. Some questions at the beginning part was very easy, but then the last few questions sort of like more last questions is just like a hierarchical one, which takes a little bit time to get it. Okay, so trying to digest this idea. So this is not easy topic. Typically, just let you know that today's lesson, this week's lesson, and the last week's lesson was not covered in the previous semesters. So they are pretty advanced. Okay, let me stop here. See whether anybody has a question. So I'm going to stop the recording.